Hello friends, today I am discussing about the most important chapter of science class 8 from which minimum 2 to 4 questions are asked in every exam, so it is most important. So let's start without wasting of time. Chapter number is 13. Chapter name is light. The world is largely known through the sense. The sense of sight is one of the most important senses. Through it, we see mountains, rivers, trees, plants, chairs, people, and so many other things around us. We also see clouds, rainbow, and birds flying in the sky. At night, we see the moon and stars. You are able to see the words and sentences printed on this page. How is seeing made possible? Okay. Next, what makes things visible? Have you ever thought how we see various objects? आपने सोचा होगा कि कैसे हम किसी भी ऑब्जेक्ट को देख पाते हैं. You may say that eyes see the object, but can you see an object in the dark? What? It means that I alone cannot see any object. इससे मतलब निकलता है, अर्थ निकलता है कि आई आँख जो है अकेले किसी भी ऑब्जेक्ट को, किसी भी पदार्थ को, किसी भी वस्तु को अकेले नहीं देख सकता है. इट इज ओनली व्हेन लाइट फ्रॉम एन ऑब्जेक्ट इंटर्स आवर आइज दैट वी सी द ऑब्जेक्ट. द लाइट मे हैव been emitted by the object or may have been reflected by it. You learnt in class 7 that a polished or a shiny surfaces can act as a mirror. A mirror changes the direction of light that falls on it. Can you tell in which direction the light falling on a surface will be reflected? What? Let us find out. Law of reflection. Activity 13.1. Fix a white sheet of paper on a drawing board or a table. Take a comb and close all its opening except one in the middle. You can use a strip of black paper for this purpose. Hold the comb perpendicular to the sheet of paper. Through light from a torch through the opening of the comb from one side. Figure 13.1. Okay. With slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb. Keep the comb and the torch steady. Place a strip of plain mirror in the path of the light ray. Figure 13.1. What do you observe? What? Here figure 13.1. Arrangement for showing reflection. Got it? After striking the mirror, the ray of light is reflected in another direction. जब हम मिरर पे मतलब दर्पण पे लाइट रे को एक्सट्रैक्ट करते हैं, मतलब प्रहार करते हैं, द रे लाइट इज रिफ्लेक्टेड इन अनदर डायरेक्शन, तब जो प्रकाश की किरणें हैं वो रिफ्लेक्ट करती है अनदर डायरेक्शन में, दूसरा दिशा में। द लाइट रे विच एक्सट्रैक्ट्स एनी सरफेस इज कॉल्ड द इंसिडेंट रे, जो प्रकाश की किरणें हम किसी भी सरफेस पे एक्सट्रैक्ट करते हैं, प्रहार करते हैं किसी भी सरफेस पे, तो उस लाइट रे को हम इंसिडेंट रे कहेंगे। द रे दैट कम्स बैक फ्रॉम द सरफेस आफ्टर रिफ्लेक्शन, उसके बाद जो प्रकाश रिफ्लेक्ट होके सरफेस पे से दूसरे डायरेक्शन की ओर जाती है, उसे हम क्या कहेंगे? रिफ्लेक्टेड रे कहेंगे। द रे दैट कम बैक फ्रॉम द सरफेस आफ्टर रिफ्लेक्शन इज नोन एज रिफ्लेक्टेड रे। अ रे ऑफ लाइट इज एन idealization in reality. We have a narrow beam of light which is made up of several rays. For simplicity, we use the term ray for a narrow beam of light. Draw lines showing the position of the line. Draw lines showing the position of the plane mirror. The incident ray and the reflected ray on the paper with the help of your friends. Remove the mirror and the comb. Draw a line making an angle of 90 degree to the line, representing the mirror at the point where the incident ray strikes the mirror. This line is known as the normal to the reflecting surfaces at that point. Figure 13.2. The angle between the normal and the incident ray is called the angle of incidence. The angle between the normal and incident ray. अभिलंब और आपतित किरण के बीच के जो कोण होते हैं उसको क्या कहेंगे? एंगल ऑफ इंसिडेंस, जिसे कोण आई से रिप्रेजेंट करते हैं। द एंगल बिटवीन द नॉर्मल एंड द रिफ्लेक्टेड रे इज नोन एज एंगल ऑफ रिफ्लेक्शन। अभिलंब और रिफ्लेक्टेड रे के बीच के जो कोण होते हैं उसको हम क्या कहेंगे? एंगल ऑफ रिफ्लेक्शन। फिगर 13.3 मेजर द एंगल ऑफ इंसिडेंस एंड द एंगल ऑफ रिफ्लेक्शन. रिपीट द एक्टिविटी सेवरल टाइम्स by changing the angle of incidence. Enter the data in table 13.1. यहाँ पे आप देख सकते हो ये एक रिफ्लेक्टेड सरफेस है. गॉट इट. इधर से ये लाइट आई और इधर से ये क्या है? ये नॉर्मल है. तो ये इंसिडेंट रे और ये नॉर्मल के बीच का जो ये कोण होगा इसको क्या कहेंगे? एंगल ऑफ इंसिडेंस. और ये नॉर्मल और ये रिफ्लेक्टेड रे के बीच का जो ये कोण होगा उसको क्या कहेंगे? एंगल ऑफ रिफ्लेक्शन. होप यू विल अंडरस्टूड. गॉट इट. टेबल 13.1 एंगल ऑफ इंसिडेंस एंड रिफ्लेक्शन. सीरियल नंबर एंगल ऑफ इंसिडेंस. Next, angle of reflection. Got it? Do you see any relation between the angle of incidence and the angle of reflection? Are they approximately equal? What if the experiment is carried out carefully, if the experiment is carried out carefully, it is seen that the angle of incidence is always equal to the angle of reflection. This is one of the law of reflection. यहाँ पे क्या कहते हैं, इफ़ द एक्सपेरिमेंट इज कैरिड आउट केयरफुली, यदि आप एक्सपेरिमेंट को केयरफुली देखते हैं और समझते हैं, इट इज सीन दैट, यह देखने को मिलता है, द एंगल ऑफ इंसिडेंस, जो आपतित कोण के जो एंगल होते हैं, इज ऑलवेज इक्वल टू द एंगल ऑफ रिफ्लेक्शन, वो परावर्तित कोण के एंगल के इक्वल होते हैं. दिस इज वन ऑफ द लॉ ऑफ रिफ्लेक्शन, इसे ही क्या कहेंगे हम, प्रकाश का परावर्तन का नियम. लेट अस परफॉर्म अनदर एक्टिविटी ऑन रिफ्लेक्शन. व्हाट वुड हैपन इफ आई थ्रू द लाइट ऑन द mirror along the normal. Activity 13.2. Perform activity 13.1 again. This time use a sheet of stiff paper or a chart paper. Let the sheet project a little beyond the edge of the table. Figure 13.4. Cut the projecting portion of the sheet in the middle. Look at the reflected ray. Make sure that the reflected ray extends to the projected portion of the paper. Bend that part of the projected portion on which the reflected ray falls. Can you still see the reflected ray? What? Bring the paper back to the original. Got it? Position. Can you see the reflected ray again? What? What do you infer? Figure 13.4 A, B. Incident ray, reflected ray and the normal at the point of incidence lie in the same plane. When the whole sheet of paper is spread on the table, it represents one plane. The incident ray, the normal at the point of incidence, and the reflected ray are all in this plane. When you bend the paper, you create a plane different from the plane in which the incidence ray and the normal lie. Then you do not see the reflected ray. What does it indicate? What? It indicates that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. This is another law of reflection. Paley and Bujo performed the above activities outside the classroom. With the sun as the source of light instead of a torch, you too can use the sun as a source of light. Next, these activities can also be performed by making use of the ray extract apparatus available in the kit prepared by NCERT. Bujo remembered that in class 7 he had studied some features of the image of an object formed by a plane mirror. Paley asked him to recall those features. First, why the image erect or upside down? What? Second, was it of the same size as the object? Third, did the image appear at the same distance behind the image as the object was in front of it? Next, could it be obtained on a screen? What? Let us understand a little more about the formation of an image by a plane mirror in the following way. Activity 13.3. A source of light O is placed in front of a plane mirror PQ. Two rays OA and OC are incident on it. Figure 13.5. Can you find out the direction of the reflected ray? What? Draw normals to the surface of the mirror PQ at the point A and C. Then draw the reflected ray at the point A and C. How would you draw these rays? What? Call the reflected ray AB and CD respectively. Extend them. Further, do they meet? What? Extend them backward. Do they meet? No. What? If they meet, mark this point as I. For a viewer is I at capital E. Figure 13.5. Do the reflected rays. Here, figure 13.5, image formation in a plane mirror appear to come from the point I. Since the reflected ray do not actually meet at I, but only appear to do so, we say that a virtual image of the point O is formed at I. As you have learned already in class 7, such an image can not be obtained on a screen. Next, you may recall that in an image formed by a mirror, the left of the object appear on the right and the right appear on the left. This is known as lateral inversion. Next, we will discuss about regular and diffused reflection. Activity 13.4. Imagine that parallel rays are incident on an irregular surface as shown in figure 13.6. Remember that the law of reflection are valid at each point of the surface. Use this law to construct reflected ray at various points. Are they parallel to one another? What? You will find that these rays are reflected in different direction. Figure 13.7. Here, figure 13.6, parallel rays incident on an irregular surface. Irregular क्या होता है? जो ऊबड़ खाबड़ होता है. Got it? Here, figure 13.7, ray reflected from irregular surface. Got it? Next, when all the parallel ray reflected from a rough or irregular surface are not parallel, the reflection is known as diffused or irregular reflection. When all the parallel ray reflected from a rough or irregular surface are not parallel, the reflection is known as diffused or irregular reflection. Remember that the diffused reflection is not due to the failure of the law of reflection. It is caused by the irregularities in the reflecting surface like that of a cardboard. Got it? यहाँ पे ऐसा नहीं है, ये जो इंसिडेंट रे आती है और ये रिफ्लेक्ट जो हो रही है तो ये लॉ ऑफ रिफ्लेक्शन को फॉलो नहीं कर रहा है। यहाँ पे भी लॉ ऑफ रिफ्लेक्शन को फॉलो कर रहा है, लेकिन इरेगुलरिटीज के वजह से ये क्या हो रहा है, एक दूसरे को कहीं कहीं काट दिया जाता है। गॉट इट? कट जाता है, लेकिन लॉ ऑफ रिफ्लेक्शन यहाँ पे भी फ्लो करता है। ऑन द अदर हैंड, रिफ्लेक्शन फ्रॉम अ स्मूथ सरफेस लाइक दैट ऑफ अ मिरर इज कॉल्ड रेगुलर रिफ्लेक्शन. Figure 13.8. Images are formed by regular reflection. Got it? Next, do we see all objects due to reflected light? What? Nearly everything you see around is seen due to reflected ray. Nearly everything you see around is seen due to reflected light. Moon, for example, receives light from the sun and reflects it. That is how we see the moon. The objects which shine in the light of other objects are called illuminated objects. Can you name some other such objects? There are other objects which give their own light, such as the sun, fire, flame of a candle, and an electric lamp. Their light falls in our eyes. That is now how we see them. The objects which emit their own light are known as luminous objects. Got it? Next, I have a question. Can the reflected ray be further reflected if incident on another mirror? What? Let us find out. Reflected light can be reflected again. जो एक बार रिफ्लेक्ट हो गई है फिर वो रिफ्लेक्ट हो सकती है। ऐसा नहीं है कि एक बार रिफ्लेक्ट होगी तो सेकेंड बार नहीं होगी। Reflected light can be reflected again. Got it? Recall the last time you visit a hairdresser. See, he makes you sit in front of a mirror. After your haircut is complete, see, he holds a mirror behind you to show you how the hair has been cut. Figure 13.9. Do you know how you could see the hair at the back of your head? Here, figure 13.9, mirror at the hairdresser shop. Pehli recalls having constructed a periscope as an extended activity in class 6. The periscope makes use of two plane mirror. Can you explain how reflection from the two mirror enables you to see objects which are not visible directly? Periscopes are used in submarines, tanks, and also by soldiers in bunkers to see things outside. Multiple images. You are aware that a plane mirror forms only a single image of one an object. What happens if two plane mirrors are used in combination? What? Let us see. Here, figure 13.9, mirror at the hairdresser shop. Got it? Activity 13.5. Take two plane mirrors, set them at right angle to each other with their edge touching figure 13.10. To hinge them, you can use adhesive tape. Place a coin in between the mirror. How many images of the coin do you see? Figure 13.10. Now, hinge the mirror using the adhesive tape at different angles, say 45 degree, 60 degree, 120 degree and 180 degree, etc. Place some object, say a candle, in between them. Note down the number of images of the object in each case. Finally, set the two mirrors parallel to each other. Find out how many images of a candle placed between them are formed. Figure 13.11. Image in plane mirror parallel to each other. Got it? Can you now explain how you can see the back of your head at the hair dresser is shop? This idea of number of images formed by mirrors placed at an angle to one another is used in kaleidoscope to make numerous beautiful patterns. You can also make a kaleidoscope yourself. Kaleidoscope 13.6. To make a kaleidoscope, get 3 rectangular mirror strips, each about 15 cm long and 4 cm wide. Join them together to form a prism as shown in figure 13.12. A. Fix this arrangement of mirrors in a circular cardboard tube or tube of a thick chart paper. Make sure that the tube is slightly longer than the mirror strips. Close one end of the rub by a cardboard disc having a hole in the center through which you can see figure 13.12b. To make the disc durable, paste a piece of transparent plastic sheet under the cardboard. Figure A, Figure B, Figure C. Making a kaleidoscope. Got it? Next, disc. At the other end, touching the mirrors, fix a circular plane glass plate. Figure 13.12c. Place on this glass plate several small pieces of colored glass. Broken pieces of colored bangles. Close this end of the tube by a ground glass plate. Allow enough space for the colored piece to move around. Your kaleidoscope is ready. When you peep through the hole, you will be able to see a variety of patterns in the tube. An interesting feature of a kaleidoscope is that you will never see the same pattern again. Designers of wallpapers and fabrics and artists often use kaleidoscope to get ideas for new pattern. To make your toy attractive, you can wrap the kaleidoscope in a colored paper. Next, 13.6, sunlight, white or colored. In class 7, you learned that the sunlight is referred to as a white light. You also learned that it consists of 7 colors. Here is another activity, activity 13.7, showing that sunlight consists of several colors. Next, what is inside our eyes? We see things only when light coming from them enter our eyes. Eye is one of our most important sense organ. It is therefore important to understand its structure and working. The eye has a roughly spherical shape. The outer coat of the eye is white. It is enough so that it can protect the interior of the eye from accidents. Its transparent from part is called activity 13.7. Get a plain mirror of a suitable size. Place it in a ball katori as shown in figure 13.13. Fill the ball with water. Put this arrangement near a window in such a way that directed sunlight falls on the mirror. Adjust the position of one of the ball so that the mid reflected light will be seen to have many colors. How can you explain this? What? The mirror and water from a prism. As you learnt in class 7, this breaks up the light into its colors. A splitting of light into its color is known as dispersion of light. Rainbow is a natural phenomena showing dispersion. Here, figure 13.13, dispersion of light. Cornea, figure 13.14. Behind the cornea, we find a dark muscular structure called iris. In the iris, there is a small opening called the pupil. The sense of the pupil is controlled by the iris. The iris is that part of eye which gives it its distinctive colors. When we say that a person has green eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. Let us see how human eye, retina, optic nerves, cornea, lens, iris, ciliary muscles. Caution. For this activity, never use a laser torch. Activity 13.8. Look into your friend's eye. Observe the size of the pupil. Throw light on her eye with a torch. Observe the pupil now. Switch off the torch and observe her pupil once again. Do you notice any change in the size of the pupil? What? In which case? Why the pupil larger? What? Why do you think it was so? What? In which case do you need to allow more light in the eye when the light is dim or bright? Behind the pupil of the eye is a lens which is thicker in the center. What kind of lens is thicker at the center? What? Recall what you learned about lenses in Class 7. The lens focuses light on the back of the eye on a layer called retina. Figure 13.14. The retina contains several nerve cells. Sensation felt by the nerve cells are then transmitted to the brain through the optic nerve. There are two kinds of cells. First, cones, which are sensitive to bright light, and second, rods, which are sensitive to dim light. Cones sense color at the junction of the optic nerve and the retina. There are no sensory cells, so no vision is possible at that spot. This is called the blind spot. Its existence can be demonstrated as follows. Activity 13.9. Make a round mark and a cross on a sheet of paper with the spot to the right of the cross. Figure 13.15. The distance between two marks may be 6 to 8 cm. Hold the sheet of paper at an arm's length from the eye. Close your left eye. Look continuously at the cross. Move the sheet slowly towards you, keeping your eye on the cross. What do you find? What? Does the round mark disappear at some point? What? Now close your right eye. Look at the round mark. Now and repeat the activity. Does the cross disappear? What? The disappearance of the cross or of the round mark show that there is a point on the retina which cannot send message to the brain when light falls on it. Got it? The impression of an image does not vanish immediately from the retina. It persists there for about 1/16th of a second. So, if a still image of a moving object are flashed on the eye at a rate faster than 16 per second, then the eye perceives this object as moving. Activity 13.10. Get a square piece of cardboard of size 6 to 8 cm. Make two holes of shown in figure 13.16. Thread a string through the two holes. Draw paste a change on one side of the cardboard and a bird on the other side. Twist the string and make the card twirl rapidly. Do you see the bird in the cage? What? reverse side of cardboard, front side of cardboard, bird in cage. Got it? The movies that we see are actually a number of separate pictures in proper sequence. They are made to move across the eye, usually at the rate of 24 pictures per second, faster than 16 per second. So we see a moving picture. Got it? Nature has provided eyes with eyelids to prevent any object from entering the eye. Eyelids also shut out light when not required. Next, eye is such a wonderful instrument that it normal can clearly see distant objects as well as objects nearby. The minimum distance at which the eye can see objects distinctly varies with age. The most comfortable distance at which one can read with a normal eye is about 25 cm. The most comfortable distance at which one can read with a normal eye is about 25 cm. Got it? Some persons can see objects close to them clearly but cannot see distant objects so clearly. On the other hand, some persons cannot see objects nearby clearly but they can see distant objects quite well with suitable corrective lenses. These defects of the eye can be corrected. Sometimes, particularly in old age, eyesight becomes foggy. It is due to the eye lens becoming cloudy. When it happens, persons are said to have cataract. Sometimes, particularly in old age, eyesight becomes foggy. Okay? It is due to the eye lens becoming cloudy. When it happens, persons are said to have cataract. There is a loss of vision, sometimes extremely severe. It is possible to treat this defect. The opaque lens is removed and a new artificial lens is inserted. Modern technology has made this procedure simpler and safer. Got it? Next, care of the eye. It is necessary that you take proper care of your eyes. If there is any problem, you should go to an eye specialist. Have a regular checkup. First, if advised, use suitable spectacles. Second, too little or too much light is bad for eyes. Insufficient light causes eye strain and headache. Too much height like that of the sun are powerful. Did you know animals have eyes shaped in different ways? Eyes of a crab are quite small, but they enable the crab to look all around. So, the crab can sense even if the enemy approaches from behind. Butterflies have large eyes that seems to be made up of thousands of little eyes. Figure 13.17. They can see not only in front and the sides but the back as well. A night bird owl can see very well in the night but not during the day. On the other hand, daylight birds, kite eagles, can see well during the day but not in the night. The owl has a large cornea and a large pupil to allow more light in its eye. Also, it has on its retina a large number of rods and only a few cones. The day birds, on the other hand, have more cones and fewer rods. Next, lamp or a laser torch can injure the retina. Okay. Next, do not look at the sun or a powerful light directly. सन की तरफ डायरेक्टली नहीं देखना है, और पावरफुल कोई लाइट हो तो उसको डायरेक्टली नहीं देखना है. नेवर रब योर आइज इफ पार्टिकल्स of dust go into your eyes. Wash your eyes with clean water. If there is no improvement, go to a doctor. Next, always read at the normal distance for vision. Do not read by bringing the book too close to your eyes or keeping it too far. Next, you learnt about balanced diet in class 6. If food is deficient in some components, eyes may also suffer lack of vitamin A in foodstuffs. It is responsible for many eyes trouble. Most common amongst them is mild blindness. One should therefore include in the diet components which have vitamin A, raw, carrot, broccoli, and green vegetables such as spinach and cod liver oil are rich in vitamin A. Eggs, milk, curd, cheese, butter, and fruits such as papaya and mango are also rich in vitamin A. Next, visually impaired person can read and write. Some persons, including children, can be visually impaired. They have very limited vision to see things. Some person cannot see at all since birth. Some persons may lose their eyesight because of a disease or in injury. Such persons try to identify things by touching and listening to voice more carefully. They develop their other senses more sharply. However, additional resources can enable them to develop their capabilities further. Got it? Here is non-optical and optical aids for visually impaired. Got it? You can go through itself. Okay. Now we will discuss about what is the Braille system. The most popular resources for visual challenged person is Braille. Okay. Louis Braille, himself a visually challenged person, developed a system for visually challenged person and published in 1821. ये कौन है? लुइस ब्रेल. The present system was adopted in 1932. There is a Braille code for common language, mathematics, and scientific notation. Many Indian languages can be read using the Braille system. Got it? You can go through itself this point. Okay. Next, visually impaired people learn the Braille system by beginning with letters, then special characters and letters combination. Method depends upon recognition by touching. Each character has to be memorized. Braille texts can be produced by hand or by machine. Typewriter-like devices and printing machines have now been developed. Next, Helen A. Keller. Some visually impaired Indians have great achievement to their credit. Divakar, a child prodigy, have given amazing performance as a singer. Okay. Next, Ravindra Jain, born completely visually impaired, obtained his Sangeet Prabhakar degree from Allahabad. He had shown his excellence as a lyricist, singer, and music composer. Next, Lal Advani himself, visually impaired, established an association for special education and rehabilitation of disabled in India. Besides this, he represented India on Braille problems in UNESCO. Helen A. Keller, an American author and lecturer, is perhaps the most well known and inspiring visually challenged person. She lost her sight when she was only 18 months old, but because of her resolve and courage, she could complete her graduation from a university. She wrote a number of books, including The Story of My Life, 1903. Got it? Now we will discuss about what you have learned. First, light is reflected from all surfaces. Next, regular reflection takes place when light is incident on a smooth, polished, and regular surfaces. Next, diffused or irregular reflection takes place from rough surfaces. Next, two laws of reflection are: first, the angle of incidence is equal to the angle of reflection. Second, incident ray, reflected ray, and the normal drawn at the point of incidence to the reflecting surface lie in the same plane. Next, image formed in a plane mirror undergoes lateral inversion. Next, two mirrors inclined to each other give multiple images. Next, beautiful patterns are formed in a kaleidoscope because of multiple reflections. Next, sunlight, called white light, consists of 7 colors. Next, a splitting of light into its constituents colors is known as dispersion. Next, parts of the eye are cornea, iris, pupil, lens, retina, and optic nerves. Next, a normal eye can see nearby and distant objects clearly. Next, visually impaired person can read and write using the braille system. Next or last, visually impaired person developed their other senses more sharply to improve their interaction with their environment. So thank you friends. Hope you will learn something new. Here is some keywords you can go through itself. तो होप कि आपने बहुत कुछ सीखा होगा इस चैप्टर में। आज क्लास 8th की सभी सेशन सभी क्लासें जो साइंस की है वो ख़त्म होती है। तो हम उम्मीद करते हैं कि आपने बहुत कुछ सीखा होगा। इसको आप 1 से 2 बार यदि गो थ्रू हो जाएंगे, सुन लेंगे, तो मुझे लगता है कि आप बहुत कुछ नया चीज़ सीखेंगे और आपकी अंडरस्टैंडिंग बढ़ेगी। ओके, तो थैंक यू फॉर वॉचिंग दिस वीडियो। राधे राधे।